All right, so lesson 8, page 68, 69, lesson 8, scale drawings and maps. Again, going to need that ruler today. First question, we will not need the ruler. Two cities are 243 miles apart. That's obviously the distance. It takes a train 4 hours to travel between them at a constant speed. A car is traveling 65 miles an hour. Who is traveling faster? Now the key for these is you need to compare apples to apples. You need to compare speed for both things. Do we know the speed of the train?
No.
You do not. So in order to compare them, you need to make them the same. Okay, so how many miles did the train travel? 243. And how long did it take the train to get there? 4. So we got to figure out miles per hour, miles divided by hours, to get the speed of the train. How many times does 4 go into 24? 6. How about 4 into 3? 0. And we can already see, is it going to be more or less than the car? Less. It's going to be 60 point some miles per hour. We can stop right now. So the train is going about 60 miles per hour. Car is going 65. So who is traveling faster? The car. It does say be prepared to explain your reasoning. Well, car is going 65 miles per hour, while the train is going about 60 miles per hour. Obviously 65 is bigger than 60. Okay, number 1. Connor, would you read it, please?
A driver is traveling at a constant speed on the interstate 90 outside Chicago. If she traveled from point A to point B in 8 minutes, did she obey the speed limit of 55 miles an hour? Explain the reason.
All right, so the speed limit's 55. She made it in 8 minutes. Do you have any idea how far it is? Okay, so we're going to have to find that out. The map is on the next page. Okay, so she traveled from point A to point B. So first of all, let's measure the scale and see if we can agree on a scale. So we can either use centimeters, looks like about 2.5, which is kind of annoying, right? Or it's pretty close to an inch. So should we use inch? All right, so let's make a little note that 1 inch equals
1 inch equals 2 miles.
2 miles. That's our scale. All right, now, can I measure directly from point A to point B? Why? Yeah, you're driving a car, right? Okay. So we got to measure all the way to this point before that person's going to head south. Would you say about 3 1/4? Okay, so I'm going to make a little note that that's 3.25 inches. And would you say about 3/4 of an inch down? Okay. So how many total inches did I go? 4 inches. So let's go back to where the problem is. So according to the map, I went 4 inches. And my scale was 1 inch equals 2 miles. So how many total miles did she drive? 8 miles. So I went 8 miles in 8 minutes. My speed is in miles per hour. I gotta figure out if I'm going fast enough. So again, Miles per hour and miles per minute are not the same label. Does anybody know how I get miles per minute into miles per hour? Or another way of asking that is how many minutes are in an hour? 60. So I would have to take that times 60 minutes in an hour. So what's 8 times 60 divided by 8? Or can you reduce 8 over 8? So it's going to be 60. Okay? 8 miles per 8 minutes is the same as 1 mile per minute, which means you can go 60 miles in 60 minutes. Right? So 60 miles per hour is how fast that person is going. And again, 8 times 60 divided by 8 is, of course, 60 as well. So is the person speeding? Yes. Explain how you know. Well, she's going 5 miles per hour over the speed limit. Yes.
But like,
Nope.
is that
Nope.
like arrestable offense? I mean,
Technically,
or a fine-
well, it's not arrestable, but if you're going 56, technically they can pull you over.
technically,
In order to get what I feel like they
give you a little cheaper.
In order to get it, in order to-
All right, next page. Number 2, Maverick.
Oh, read it?
Yes.
Oh, a traffic helicopter flew directly from point A to point B in 8 minutes. Did the helicopter travel faster or slower than the driver? Explain or show your reasoning.
All right, so let's measure from A to B. Now the helicopter doesn't have to follow the road. Okay, so what's that distance? In inches. 3 3/4, 3.75. Okay, so I'll put a little helicopter. Went 3.5 inches on my map in 8 minutes, compared to my car, which went 4 inches in 8 minutes. So I'm comparing the same amount of time, so I should be able to just answer who went faster. The car did. The car went a further distance in 8 minutes. Right? The helicopter went slower. Right? We could figure it out in regards to how many miles it went. What's 3.5 inches if 1 inch equals 2 miles? 7 miles. So the helicopter went 7 miles in real life. The car went 4 inches would be how many miles? 8. The car went 1 mile faster in the same amount of time. 1 mile further, excuse me, in the same amount of time. So, who went faster? The car. Traveled a bigger distance. In the same amount of time. All right, question 3. A cyclist rides at a constant speed of 15 miles per hour. At this speed, how long would it take the cyclist to ride from Garden City to Dodge City, Kansas? Okay, next page. There's our map. So again, our first step is let's get our scale figured out.
I say 1 centimeter equals 4 miles.
1 centimeter equals 4 miles. I'm good with that. Okay, now when you're measuring this distance, you know, the road doesn't go straight, but yet there's a lot of dips and curves. The more of those that you measure, the more accurate it will be, but also the more time consuming it will be. Okay? So do you see this little dip to start? Is that worth measuring that one by itself? No, so let's just measure straight across then. And to the nearest tenth, how far would you say that is? Because I don't think we can say a full centimeter.
About 12. 12 centimeters.
Where are you measuring to?
Yeah.
Oh, I'm measuring like
12 centimeters is what, or you did the whole thing.
yeah.
Yeah, the road doesn't go straight though. We can't do that. We'll see how close that is though. How would you say that first dip is? How far? I don't think as far as 1. I would say about 7/10. 7 or 8/10, I would say. You want to go 7 or 8? 8, all right. 0.8. All right, then it goes down a little bit. Let's measure that little part down. What do you think on that one? 0.3? All right, put that on there. We'll kind of divide this one in half. Let's go to about right here before the road starts curving. 2.5.
Yeah.
Okay. And how about to the edge of that point then? Another 2.5?
Yeah.
Good with that? Okay. So now I'm to right here. Probably down to this corner. 1? Now let's try to get all the way to this straightaway right here. You went all the way to Dodge City. I don't want to go that far. 3? 3's right here. I'm okay with that. And then go from there to Dodge City. 2.4. All right. So everybody's got the same numbers. Please add those up, see what you get. Don't shout it out loud. Faith, did you get it?
Okay. 13.9.
Okay, I did not get that, but doesn't mean mine's not right. Sophia?
12.5.
12.5? Well, these two would be 5. 6, 7, 8. 10.4. 10.4 plus 1.1. Isn't that 11.5?
That's what I got now.
Huh?
There's another.
Oh, I forgot the one in the middle right there. That's right, 12.5.
That random little.
All right, 12.5. Everybody good now? All right, let's figure out that real distance. So 1 centimeter is 4 miles. 12.5 centimeters would be how many miles? So do I multiply or divide there? Multiply. 12.5 times 4, please. And we are going to label that miles. Kaylee?
I got 50 miles.
15?
50.
50. 50. 50 miles? 50 miles? 50 miles. Good. 50 miles. 12.5 times 4 should come out very nicely. 50 miles. Now, do you remember what the question was asking? How long will it take? Okay, so if you go 50 miles at 15 miles per hour. So let me ask you this. Let's say you're driving 120 miles at 60 miles an hour. How long would it take you? 2 hours. How'd you get that? Miles divided by your speed. Miles divided by speed. Okay, could make a little note of that. If you want to get time, you take your distance divided by your rate or your speed. All right, so our distance is 50 miles. I'm just going to do it way on the bottom here. And I'm going to divide that by, our speed was 15. So this is miles divided by our speed, miles per hour. So my answer is going to be in what kind of a label? No. Hours. How long? Time. Okay. How many times 15 going to 50? 3. Notice anything? It's going to keep going, right? So it's going to be 3 hours. And let's just round it to 0.3. What is 0.3 of an hour? So 60 times 0.3.
18.
So about 3 hours and 18 minutes. Now, if you get 0.3, that's not 0.3 of an hour or a minute, it's 0.3 of an hour. So I could have said 3.3 hours. That would have been fine. Or 3 hours and 18 minutes. Okay, the Are You Ready there, right in the middle. Jada finds a map. It says, this map is not to scale. What do you think that means? Let's answer that part first. Jonas.
That like it's not a one-to-one scale. Like the map is smaller than the thing it's representing.
Yeah, it's not a perfect one-to-one scale. That means it's probably not going to have one of these where every distance is mapped out the same. Okay, maybe the city they crammed into a smaller area and just did most of the country roads or whatever. Why is this important? Why would it be important for them to note that on a map?
So we don't try to go somewhere with it?
Yeah, so you're not trying to plan a hiking trip or biking trip and you have no real idea how far that is. Okay, that could be an issue if you're planning on setting up tents somewhere in the dark or canoeing up at the Boundary Waters. Anybody's done that, it's nice to know how far you need to make it to set up camp. All right, maps with scales are useful in making calculations involve speed, time, and distance. Okay, here's an example. Okay, this is a map of Alabama from Birmingham to Montgomery. So one thing to keep in mind, you know, just like we've talked about scale and scale factors, notice how in the table they made a little chart. 1.5 hours to go 90 miles. If I double the number of miles, I would have to double the amount of time. Does that sound familiar? Just like when we did shapes. Scale factor. Okay, how do I go from 180 to 60? Divide by 3 or times a third. So what do I got to do to the time? Divide by 3 or times a third. It's the same exact thing that we did, with shapes. Now you can do it with distance, time, speed. What you do to one side, you have to do to the other. Well, it's not proportional. Okay, your homework. Only 2 questions today on page 73. The only thing I want to make note of is that scale. So I want everybody to use the same scale. So please measure that so we can agree on it. Inch doesn't work very well either. I would say 2.2. You agree with that?
Yeah.
It's not 2 though. Agree with 2.2?
Yeah.
All right. 2.2 centimeters equals 60 miles. That's what you'll use for your scale. Again, when you're measuring from Amarillo to Oklahoma City, go as straight as you can. You can't just make a straight shot. You're going to have to do some smaller measurements to be as accurate as you can and then add them up. Okay, follow that road the best you can. You don't have to do every curve, but the more you do, the more accurate you'll be. Make sure you label. Number 1, there's 2 explains there for A and B. Make sure you answer those. That'll be due tomorrow at the beginning of class.